Alrighties, hello there. Welcome to your pre-lesson video for week 1.3 decimals. Alright, so to get things kicked off, I'll first actually explain what is a decimal. So you probably have heard this many times, but here's the actual definition of a decimal. So a decimal is a fraction where the denominator is a multiple of 10, right? So if you look, for example, like 0.3 is equivalent to 3 over 10. See how the denominator is a multiple of 10, 10 itself. And then if we have like 2 and 19 over 100, see how 100 is also a multiple of 10, right? So we would write that as like 2.19. See how that's a decimal now? Because this fraction part here is a multiple of 10, right? And now to get into specifics, like what is a terminating decimal? So a terminating decimal is where the decimal does not already has like an endpoint, right? So if you look at this example, like take the fraction 1 over 4, right? That would be equivalent to 0.25. And notice how the 0.25, there's nothing after it, right? Which means that it is terminated. That is the end of how you would write the decimal. There is nothing going on past the 5, that kind of thing. Another example of like a terminating decimal is, we'll take again, 3 over 10, which is 0.3, right? There's nothing going past the 3. It's 0.3 and that's it, right? It's just fixed like that. Now, the other thing that we have is like a repeating decimal. So if, let's say, you take 1/3, right? So we could write it as like 0.33, and then we'll have this bar on top. And what this bar on top here signifies is that this 3 is repeating continuously. Actually, you would also be able to write it as 0.3 continuous, because it's, if you were to put it in a calculator, right, this 3 is repeating nonstop. It'll be like 0.333333333 and to infinity, right? Another example of like a repeating decimal is, let's see what's another good one. Right, so we look at 1 over, what was that? 1 over 11, that is repeating of like 0.09. I will put a dash on top of the 0 and the 9, because after the 9 is going to repeat as 0 again, so it'll be like 0.090909090909 to infinity. And then another good example, which is a little bit different from the one that you see, is, let's take this number, which is 7 over 22, right? So we have 0.318, but if you notice that the 1 and the 8 only has the dash on top, which means that the 3 is only mentioned once, and then the things that are repeating are the 1 and the 8. So it's going to be like 0.3181818181818, and so on. And that's how, we will be writing repeating decimals. All right. Now, if you have any questions about like terminating and repeating decimals, bring that to your deep dive lesson. Now, the next thing for us to move onwards to is rational numbers. So a rational number is any number or fraction that can be expressed as a terminating or repeating decimal, right? So like, it's like the ones that I showed you earlier. So it can be like half, it could be 1/3, it could be 7 over 22, it could be 4 over 5, right? And so on. So like these would be, and also like 0, 3, 5, because these are like either terminating decimals. Like if 3, it's 3.0, that's nothing after the 0, right? 5.0, nothing after the thing. Like 5.2, that is a terminating decimal, right? So all these will be considered a rational number. Now, the other one of it is irrational number. So an irrational number, also known as a non-rational number, right, is a real number that cannot be written as a fraction or a terminating or repeating decimal. So that means it's like after the decimal, it'll be like numbers on end without like any pattern to it, right? So a good example of like an irrational number is like square root 2, right? Because if you were to put that in the calculator, let's see what we get. So square root 2 would then give us, I'm just going to write the first few numbers of it, which is like 1.414213562, and then continuous, like it's never ending, and as you can see there's no pattern, so we would consider this an irrational number, right? Same thing with pi, right? So pi is also considered an irrational number because it doesn't have a pattern to its decimals. If you look, it's like 3.142. Oh wait, sorry. It is going to be, the exact one is going to be 3.141592654, and then continue on, right? So as you can see, these two examples, they don't have any patterns in the decimals, which is why we can't write them as a fraction, or we can't put the bar on top of the numbers because it's not a repeating decimal. There's no pattern to it, and that's why it's considered an irrational number. All right. Now, if you have any more confusions about rational and irrational numbers, again, bring this during your deep dive lesson. All right, now the next thing that we're moving on to is converting decimals to fractions, right? This is for the case where they give you fractions and decimals, and they ask you to arrange it from ascending or descending order, it depends. So it would be easiest, obviously, if you convert the fractions to decimals, but sometimes you might want to do it the other way, so it really depends. So I'm going to show you anyways, both ways. So to first convert decimals to fractions, let's look. We have 1, 2, 3. Because there are 3 decimal places, that means we know the number, if we put it as a fraction, it's going to be over 1,000, right? Because 1,000 has 3 zeros. So 1, 2, 3, and then we're going to put 3, 1, 5. Oh, look, it's a fraction. But if you notice, we can actually simplify it, right? Because 315 and 1,000 can both be divided by at least 5, if not more. So if we look, they can both be divided by, yeah, so it is 5. So we look, 315 divided by 5, let's put, so divided by 5, to simplify it, we would get 63 over 200, right? And now if we check and see, yeah, so it'll be 63 over 200, and that's the furthest it can be simplified into, and so that's how you would convert decimals to fractions. You want to see how many decimal places you have in the decimal in the number, so in this case 3. And then we know, because there's 3 decimal places, that means we need to pick a multiple of 10 that has 3 zeros. So in this case, 1,000, right? So we know it's going to be 315, so 315 over 1,000, put as that. And then if we can simplify it, we would. And in this case, we could. So we divide both sides, the top and bottom, by 5, because that's what they both can be simplified with, to give us 63 over 200, and that's what you will get. So 0.315 is equivalent to 63 over 200. All right, now for the opposite. So to convert fractions to decimals, we would first look at this. Easiest way is, obviously, if you look at this big number here, we know it's going to be easily 1 point something, right? So then the only thing that we would need to do is 8 divided by 11. So we'll set up again like this. We'll put 11 here. Oh, that's supposed to be 11. Let me rewrite that. There we go, 11, and then this is 8. Right? So let's look. We know that nothing of 11 can go into 8, so we're just going to put a 0 here, which is fine. So 0. Drop all these down. So now we know. Okay, the closest multiple of 11 to 80 is going to be 77, right? So 11 times 7 is 77. So let's put that here, 3, and then we'll put another 0 here. So we're going to see if there's like, if this is going to be a terminating decimal or repeating decimal. So we'll have to do this for a bit, right? So from here, drop a 0. Closest multiple of 11 to 30 is 22, so we'll put 2 there, minus 22, 8, 0, put another 0, again 7, 0, and then let me bring that to the side here, so it'll be 0, oh wait, that's not 80, whoops, that would be 77, there we go. Bring that to the side, we would again get 3, and then bring down another 0, and then 2, again. So as you can see, it's just going to be like a repeating pattern on and on with 7 and 2 repeating itself, right? So that means we can write this decimal as 1.72 with the bar on top of 72 because that's the part that's repeating, right? Does that make sense? If it's still confusing a bit, again, bring it to your deep dive lesson. And that's how you convert fractions to decimals. Now on to the next thing that's really important because sometimes your answer, wants you to round it to the nearest tens, hundreds, thousands. It's easy when they say round it to 1 decimal place, 3 decimal place, but sometimes it's confusing with when they say tens, hundreds, thousands, or nearest whole number integer, right? So if we look at place values, this is the tenth, this is the hundredth, thousandth, 10,000, right? So if they say round it to the nearest tenths, you want to look at this, right? So let's look at the number right next to 4 in this case, which is 5. Since 5 is always called a big number, we would round the number up. So that means when we round it up, we would get it as 1.5, and that's how you would round this number to the nearest tenths, okay? And now if they say round it to the nearest hundredths, so we look at number 5, right? That's in the hundredths place. So we look at the number to the right, which is 8. Since 8 is a big number, we're going to round the number up, right? So the first 2 numbers, we're not going to touch it. So it's still going to be 1.4, and then 5 is the one that's going to be affected. So it's going to round up by 1. So it becomes 1.46, right? Thousands, as you can see, 8 is in the thousands, so we'll look at the number to the right of it, which is 7. Alright, since 7 is a big number, we would again round it up, so 1.45 remains the same, and the only thing that's being affected is the 8, and since we're rounding up, that becomes 9. Alright, now when it says round it to the nearest whole number integer, means round it to with no decimal. So you're going to look at the number that's in the ones place. So the number that's in the ones place is the number 1, like right here. Okay, so the number to the right of that is 4, and since 4 is a smaller number, that means we're going to round down, which means that 1 is not going to be affected. So if we were to round this decimal 1.4587 to the nearest whole number or integer, it would just be 1. Alright, now if you have any questions about this, again, bring your question during the deep dive lesson. Alright, now with adding and subtracting decimals, just make sure big thing is set it up. When you set it up like this, make sure you are aligning everything according to the decimal point. Alright, the decimal point here has to be aligned with each other, because if it's not, then everything will not be in the right place value, and then your calculation will go wrong. So again, you would want to do like your normal calculations here, and so 3.0550 minus 2.05 9985. Let's see what that will give us. Okay. We need to borrow 10, so this becomes 4. That's 5. Again, this needs to borrow 14. 3, so 14 minus 8 is 6. 3 is too small, so we need to borrow, but we can't borrow from 0 because there's nothing, right? So that means we've got to borrow from here. This becomes 10, but because we need to borrow, because 3 needs to borrow from something, we borrow it from the 10 now. So this becomes 9. This becomes 13. So 13 minus 9 is 4. 9 minus 9 is 0. And then 2 minus 2 is 0. And that's how you do it. Alright? So just like I said, remember, for adding and subtracting decimals, make sure the decimal points are in line. If not, it will go wrong. Now, with multiplying and dividing decimals, I'm going to teach you a little neat trick. So with multiplying decimals, first thing we're going to identify is how many decimal points are there altogether. So if you look, 1, 2, 3. That means when we get our answer, it will have 3 decimal places, right? And so now when I'm multiplying it, here's what I want to do. So we're going to put 1.07 times 8.3. This one doesn't really matter where the decimal point is. Just remember, your final answer should have 3 decimal places. So I'm just going to go ahead and do the multiplying like normal. So 7 times 3 is 21. So we'll put a 2 here, and then 3 times 0 is 0 plus 2, so 2. 3 times 1 is 3. We'll put plus. Drop a 0 first before we think, and then before we multiply, and then 8 times 7 is 56. So that gets a 5 there, and then 8 times 0 plus 5 is 5. Right? And actually, let's get rid of this decimal first. Put that out of habit. Alright, now from here, I go 8 times 1 is 8. So see how there's no decimals there right now? So now we're going to add them all together. So we get 1, 8, 8, 8. Right? And then from here, let's bring it to the side. So we have 8, 8, 8, 1. And then we know that the answer should have 3 decimal places, right? So we start from here, and this is what I call hump. So in order to determine where the decimal will end, we would do 3 humps. So 1, 2, 3. That's where your decimal should be. Right, so that means your final answer should be 8.881. See how there are 3 decimal places in your answer now? And that's how you would multiply with decimals. If you have any questions about it, again, bring it to your deep dive lesson. Now, similar thing with dividing is you would want to actually shift all these first before dividing. So we'll go according to the number that you're dividing it by. So if you look 0.3, we want this as a whole number and not a decimal. So we'll shift this 2 places. So 1, 2, it becomes 34. Same thing with this, because we shifted this 2 places to the right, we need to shift this also 2 places to the right. So it becomes becomes 9894. And then from there, we'll be able to do our long division. Ooh, hold on a second. There we go. A little error there. Oh, there we go. Alright, so we'll do 9894 divided by 34, and then let's see, 98 closest multiple of 34 to 98 is 34 times 2, which is 68. That's going to give us 30, and then we're going to drop down the 9, and then the closest multiple of 34 to 309 is, let's see, is going to be 34 times 9, which is 306. Get gives us 3, and then bring down to 4, and obviously we know closest multiple of 34 to 34 is itself, so 34 times 1, and boom, right? So that means we won't have any decimals in this answer just because we do not have any remainders of 0 after this, right? And so that means 98.4 divided by 0.34 is 291. If let's say like here we're like it didn't have a remainder of 0, they're like maybe 1, we'll put a point here and then add a 0, and then from there onwards you'll put a point here and then whatever numbers. So like in this case maybe it was like we'll divide it like 99900, it'll be like 291 point something something something. All right, and so that's it for like multiplying and dividing decimals. And again, with like order of operations with decimals, it's the same thing as like your integers and fractions. You want to use PEMDAS, all right, in order to solve it. Alrighty, so, well, this is the end of your pre-lesson video for week 1.3 decimals. If you have any questions about any other topic that we just went through, again, bring it to your deep dive lesson. Have a good rest of your day.